last time, yesterday, correct? We did page 41, 42. It's pretty much done. So taking a look at page 43 and 44. So what's something that happened with inequalities that changed the game a little bit? So we had problems that look like this. What kind of problem was that? And so if your problem dictates that it should be and it looks like that, no test points needed. Or you might have had this type of problem. Shading that way, and then shading that way, right? And that's an OR. Hey, good work. Yeah. Okay. Sorry about that. So we were talking about, we have and problems, we have or problems. So a lot of times an and problem, if it's presented as an and problem and it looks like that kind of graph, there's no reason to do test points. If it presents itself as an or problem, how do you know it's an or problem? What's the most obvious? Yeah. Okay. Well, what sticks out in the original problem that you know it's an or problem? The most obvious thing. What? Or. Yeah, the two-letter word or is in there. So if you're given an or problem and your graph that you look at looks similar to this, no test points are needed. If you're given another problem that doesn't have the word or in it, it's just all put together already, it's typically being directed as an and problem. So if the and problem takes place and it looks like that, no worries about test points. If the or problem takes place and it presents itself like that, no worries on changing it. So let's talk about if we were to work out some problem. Let's say we had 2 is less than or equal to x, which is less than 5. Let's say that's what the problem worked down to. So you probably would have had something like this that it could have resulted in. Okay, so you want values that are bigger than 2 and equal to 2 and less than 5. A solid dot. That. Boom, it's done. That is an and problem. An and problem will normally be put together like that. Yes, we could have things that are switched in the middle. We could have 3x plus 7 or something like that in the middle that we have to solve to. That's 2 problems put together. It's an and problem. If your result looks like this, you don't have to worry about finding a region to shade. Okay? It's when you have an and problem that does something like this. So we would have 5, we would have 7, we'd have a solid dot here, this is going this way, and then we have an open dot here going this way as far as the shading goes. Okay, now we have both arrows going the same way. So we have to understand that we have this region here for our graph, we have this region here for our graph, and we have this region here for our graph. There's 3 regions that have to work. So if you were to take and plug into your original problem a test point, figure out if it's an and problem. Are you looking for false, false, true, false, or true, true? And problem, true, 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 false, or false, false? Are we ever looking for a false, false? No. Well, it depends, yeah, but you're not going to shade that false false. The true false works with the or. And then the true true works with the and. So this problem here, the only place that it really exists is here. This is the only part of this problem that exists to make it true. So what happens is if I were to have gone through and done test points, this region here is false and false, this is true and false, and this is true and true when we pick a test point. A test point is just an individual number that's in that region. What's the number between 5 and 7? That would work. I don't know, 6. It's right in between. What's a number that's smaller than 5? I don't know, 0? What's a number that's bigger than 7? 10 maybe? So there's different things that we could plug into that would make it true. So that's just some things that we have to fundamentally know exists. So looking at page 43 and 44, is there anything there that you would like me to go over? 43 and 44. The back? Yeah? Go ahead. 21 on the back, all right?
16 and 17.
All right, I'll come to 16 and 17. Remind me as soon as I'm done with this one, I'll get to this. Is that cool?
Good.
All right, quick question. Yes, we have X all over the place on this problem. But how is this problem being presented? Is it being presented as an and problem or an or problem? And or? And, how do you know? Because you don't see the word or. I mean, that's the big deciding factor. There's nothing more other than, it's really bad math if they have this as an or problem. It's not accepted. But if you have the word or, that means it's an or problem. If you don't, then it has to be presenting itself as an and problem. An and problem, you might have to have a test point, and you're looking for true and true to happen. So this one will definitely take place for us. I need to remind everyone that this part's going to go with both problems. We're going to break this into two problems. So I have 4x minus 9 less than 9x plus 6. Then I have 9x plus 6 is less than 4x plus 16. Is that okay? Is there anything that I've just done where I go time out? Why didn't the 9x just go with the left and the 6 go with the right? Good? All right, so let's solve each. We want to get x alone. So I don't know, maybe subtract 9x, subtract 9x. You might have chosen a different route, but you're going to get the same answer. Add 9, add 9. Negative 5x is less than, that's 9, 15. Divide each side by negative 5. What happens when we divide by negative? The inequality sign does what? Switches. And 15 over negative 5 is negative 3. Is everyone okay with that so far? Okay, let's solve the other one as well. Let's see. I'll subtract 4x and 4x. 5x plus 6 is less than 16. Subtract 6, subtract 6. 5x is less than 10. Divide by 5. X is less than 2. Okay, what kind of problem did we say this was? And. The reason it's and is because it doesn't have what?
Or.
I mean, is that simple to decipher the difference between them? So and problems should present themselves where they're shading together. Agreed? But sometimes we might have going this way, or splitting either way. Okay, so let's improve this. Well, let's look at this on the number line. Okay, so I have negative 3 here. 0 might be here. 2 is about here. Is that okay so far? No. I have an open dot going this way. I have an open dot going this way. So we're shading together. Does this appear, it was presented originally as an and problem. Is this a traditional and graph? Like we didn't have signs going the same way. We had them come together, correct?
Correct.
So with that, do I need to worry about a test point? An and graph comes together. If your solution comes to this type of solution, which is what an AND graph should look like, there's no reason to go and try and go further on that. Okay? So if I want to write this in interval notation, do I have square brackets, rounded brackets, or one of each? Before you answer, take a look. What does this mean? Rounded. Parentheses, right? We don't include those points. So I'm going to go from -3 to 2. Done. That's interval notation. Okay, so you're using the graph to apply what this is. There was no reason to pick a test point because an AND graph comes together. If we had something that was a little goofy, we have to choose some test points to make sure things work. Okay, you had some others you want to see? I'm sorry. 16 and 17. So number 16, we'll go to first. We have -6 is less than 1/3. 6y plus 12 is less than 14. What kind of problem does this appear to be presenting itself as? And. How do you know? That doesn't say or. So the word or is nowhere part of this problem. So this is presenting itself as an and problem. And problems should overlap each other, like the last problem. If it presents that when we graph it, we don't have to pick test points. If it gets goofy, then we have to take a look at some test points. So let's, I'm not going to distribute, I'm sorry. Do that. So I'm going to break this into two problems. That goes with both, yes? What do you think? That all make sense? Okay, so let's try and work this out. So I'm going to distribute the 1/3 over the parentheses. What's 1/3 of 6? What's 1/3 of 12? Everyone okay with that? Subtract 4, subtract 4. Looks like we're getting -10 is less than 2y. Divide by 2, divide by 2. We're going to get -5 is less than y. Now I'm just going to flip this over just so I can see it a little bit better. So that flips over. Hey, did that sign flip over from here to here because I multiplied or divided by a negative? No, I just rewrote the problem. Okay, so let's work this problem. What's 1/3 of 6? You guys told me it was 2y. 1/3 of 12, you told me it was 4. It's less than 14. Subtract 4, subtract 4. Divide by 2, divide by 2. Okay, so here are our two regions. Okay, what kind of problem was this originally? And. All right, so let's see if we can get that to present itself. So I have -5 here, 0 somewhere in the middle, and then 5 over here. Let's see, I have an open circle shading this way. And I have an open circle shading this way. So I'm shading in the middle. Does that look like a regular AND graph?
Yes.
Yes. Do I need to pick a test point at that point? No. Okay, so that looks like a normal graph, no test point needed. And am I going to have parentheses or square brackets for my endpoints? Parentheses, because they're both open circles. Done. That's your interval notation. That's all you have. Okay? Why did we not need to pick a test point?
Because it was the problem was solved like it was shown.
Yeah. So and problems look like this always. There's no reason to pick a test point if it shows how it should. Okay. What 16 was the next one? Is that what? Or 17? Okay. What kind of problem is this?
Or
How do you know?
it says it.
Yeah, the word or is there. Now, and problems come together. Or problems do what when they present normally? They go opposite. They don't have an overlap, right? So if the or problem, if our answer when we graph it just shows going outside, there is no reason to pick test points. But if it shows different, like it looks like an and graph, or both arrows are going the same, we need to figure out some test points. So we distribute here and here. So I get 42 is less than 18 minus 6k. Subtracting 18, what's 42 minus 18? How much is it? 36? 24? I like 24. Is that right? Divide each side by -6. What's going to happen now? That's negative. That's K. What happens to our sign?
Flips.
It switches directions. It switches directions because we divided by that. Okay? So now I'm just going to flip it over this way to go off of this answer, just so I can graph it. Okay? Did I flip it here because I multiplied or divided by negative? No, I switched the entire answer over because I wanted to have my variable, my letter first. Okay? All right, so second problem, let's take a look. Half of 14 is what? 7, so I get 7K. And half of 8 is 4. Are we good there? I'm going to add 4 to both sides. Is that okay? Divide by 7. Okay. So it's an OR problem. So if it's going outside, we don't have to pick test points. Yeah.
So for these types of problems, you're not multiplying, you're dividing the denominator by the.
Yeah.
Okay.
All right. So -4 is here. 0 about here. 2 is about here. All right. So if it's an OR problem, it should be shading away. So I have an open circle going this way. Hey, where's this graphing to? Where's that going to? Which one? There you go. And then 2, I have a closed circle here. Where's this going to? Infinity. Okay. Does this present itself as an OR problem right now?
Yes.
Do I need to pick test points? No. So this is going to be -infinity to 4, rounded bracket at the -4, excuse me. And then I'm going to put the word OR. The reason we do that is because it's a OR problem. And then I have a square bracket here because it's a closed circle to infinity. Done. That's interval notation of that problem. How do we feel? Feeling all right? Are there any others you would like to take a look at from last night's homework? Yeah. 18. Okay. 18. I have 8w minus 5 is greater than 12w plus 3, or 3 is greater than -3/4 w plus 9. What kind of problem is this? How do you know?
It says OR.
It says OR. I mean, distinguishing it as and or has nothing to do with math. It has the fact that can you read a two-letter word or? If there's not that two-letter word or, it has to be an and problem. All right, so let's work out each problem. So I don't know, maybe subtract 8w from both sides on this one. So that's going to be -5 is greater than 4w plus 3. Subtract 3. Those cancel. -8 is greater than 4w. Divide by 4 because 4 and w are being held together by multiplication. And I'm just going to flip this one over so I have my variable first. So I'm just doing a flip. Is that okay? And then second problem, let's see, subtract 9 perhaps from both sides. I guess I could have cleared the denominator, but we'll see what happens. Let's do it slow. Let's multiply both sides times 4. So that's -24 is greater than -3w. Divide each side by -3. So that's negative or positive. That sign flips directions. And then I'm going to flip the whole thing over just so I have it going correct. Okay, so this was an OR problem. So if it's shading outside, not overlapping at all, we don't need to do anything else. So I have -2 here. I have 8 here. Of course, 0 is about here. So I have an open circle going to where? -infinity. And I have an open dot here going where? Infinity. Okay. Does that look like a normal OR problem? No overlap, right? So I don't have to pick any test points. So this is going to go from negative infinity to negative 2, rounded bracket on each, because we're not including it, or 8 to infinity, and again, rounded brackets. And again, that's your interval notation. Is there anything else you would like to see? Anything else you'd like to see? Going once. Going twice. Okay. This is what we're going to do for the remainder of the period. So I want you to have out on your desk pages 41, 42. That was what was assigned on Monday, correct? But I didn't check it off. And then pages 43 and 44. That's what I assigned last night. So I want both those out. I'm going to come by and I'll put points in. I'm not going to actually physically pick these up, but I will put points in the grade book for you, okay? Today is Wednesday. So we're modifying a few things. I was taking a look at our stuff, and we can totally do this. So I'm going to give you the take-home test to work on right now. Okay? What is awesome about the take-home test? What did we kind of discover the take-home test from the last chapter looked like in comparison? Go ahead.
You can do it with anybody except you.
Yeah, do it with anybody. Now, you can ask me clarifying questions. It's awesome. You can use any materials you want. You can work with each other. You can use my videos if you want. You can ask other teachers. You just can't ask me. But if you have like, I just don't understand what he's asking, I can clarify for you. But I can't sit down and work it out with you. What's the benefit of the take-home test? You can take it home. You can get a good score on it, and it counts as in the test category. It's worth 25% of what the overall test is worth. So you don't want to make it worth nothing, okay? You don't want to make it worth nothing. Don't be that kid that just puts random answers in and hoping you might have found one of them being right. Be that kid that applied yourself on each and every one of them, because when I grade the take-home test, I grade it as right or wrong. I don't put any partial points in. Okay? It's graded as right or wrong without any partial points. Okay? Everyone know what we're going to do? So for the remainder of the period, I'm going to come around. I need to make sure those are both out. Please make sure your names are on those. I'm coming around. You're not You don't need to pass them in. I will just come by and mark them off in the grade book. And then I'll give you the take-home test. So then tomorrow, which is Thursday, we're going to do the in-class test. And then Friday, we're starting a new unit.
Already?
Already. This was a quick chapter.
What's the next one?
More math.
You make us do that today.
Maybe a little
And
Latin.
then Thursday, we should
Go
have
over
no
it.
I understand. Thursday we won't be any homework because you'll have the in-class test. See, you already talked me out of it. Good. All right, everyone know what to do? I'm going to freeze this up on the board.
You didn't finish it.
Freeze. Now it's frozen. I'm going to flip the light switch on. I'm going to come around and check off your homework. Yeah?
I'm not sure I'm gonna be here tomorrow.
Okay. Gotcha. So we'll have you take it next time. Is that all right? I'll try and make sure you take care of it. All right, let me get you the take-home test.
Was the test originally going to be on Friday?
It was, and then I went back and we looked at our material, and it was.